Students, in this video, let us discuss about the electric motor. Okay. So for that, first let us understand how the current carrying coil behaves in uniform magnetic field. So now these lines, the arrows which I drawed, indicates uniform magnetic field, right? Uniform magnetic field. Okay. Now, let us place a rectangular coil A, B, C, D in this uniform magnetic field. Right? Now connect the ends of the coil to the battery. Here we didn't show the battery connection to the battery. Now let us assume that current is flowing in this direction. See the arrow marks. So A to B, B to C, C to D, and next D to A in such a way. The current direction. Now this is the current direction in the coil. Right? The current direction. Okay. Now, when current carrying wire is placed in a magnetic field, what happens? Magnetic field exerts a force on the charge carriers flowing through this wire. That is the current. Current means the motion of charged carriers. Right? That is, the magnetic field is exerting magnetic force on these sides of a coil. Can I say magnetic field is exerting the force on these sides. Four sides are there: A, B, B, C, C, D and D, A. Four sides are there. Right? Now here, let us find out the direction of magnetic force. What will be the direction of magnetic force? How we will find? We will use right hand rule to find the direction of magnetic force. Okay. So what does the right hand rule says? Right hand rule says that if we stretch our three fingers of right hand mutually perpendicular to each other, forefinger will be representing current direction, middle finger magnetic field direction, thumb magnetic force direction. So forefinger, what it represents? Current direction. Middle finger, what it represents? Direction of magnetic field. And thumb represents the direction of magnetic force. Alright. Now in these four phases, let us find out the direction of this magnetic force using right hand rule. Now right hand rule. The direction of magnetic field, arrow mark C, positive X direction. So my middle finger, which indicates the direction of magnetic field, will be in direction of magnetic field. Now see, here this finger I kept in this direction. Okay, in this direction. Now forefinger in a current direction and thumb. See, in such a way. Now current direction forefinger, field direction middle finger, thumb is pointing inwards into the paper. So into symbol I'm keeping why? Thumb is pointing into the paper, means force is into the paper on AB face. On AB face, force is into the paper. Right? Now next, the opposite face CD. Let us find out the force. Magnetic field, middle finger. Okay. Now current is downwards, you see. Okay. Downwards. And thumb, you see, upwards in such a way. So this is the middle finger and this is the thumb. Thumb in upwards, outwards. So forefinger, current direction, downwards. Now this middle finger is in the direction of magnetic field and thumb is pointing upwards. Means dot I am keeping. Force is out of page on CD face. On CD face, force is out of paper or out of page. Out of paper or out of page. Now see these two faces. Now I'm drawing AB face. Okay. How this face is? Current is in this direction. Now this is magnetic field direction. Now a 90-degree angle is present between the field direction and AB face. Similarly, CD face. So here also an angle 90 degrees means AB and CD are perpendicular to the AD and AB and CD faces are perpendicular to the field direction. Or B, can I write? I can write. Are perpendicular to the field direction. Okay. So here into the page force. Here out of page. Right. Now next, let us talk about the other two faces also. Right. BC and DA, other two faces also. Now see, this is the direction of current, the arrow mark, and this is the direction of field. So here and here also, the direction of current, negative x-axis, and field direction. So can I say the current and field directions both are parallel? Both are parallel. Right here, this current direction, field direction, both are mutually perpendicular to each other. Okay, these two faces, or I can say the current passing through these two faces, that is AB and CD, perpendicular to the field direction. So the magnetic force effect will be on AB and CD faces. But in case of BC and DA faces, the current is parallel to that of the field direction. Both are parallel, you see. Both are parallel. Here it is in opposite direction, but both are parallel, flowing parallel. So here on these two faces, magnetic force will not show its effect or will not act, because the major condition of right hand rule is these three fingers must be mutually perpendicular to each other. What I said, the force is perpendicular to other two, that is the current and field direction. But here what is happening? Here in these three, two are parallel to each other, only force is here. Okay. These two are parallel to each other. Actually, three must be perpendicular to each other. But it is not happening here. So, magnetic force will not act on these two faces, A, B and DA. Then what happens? But here you see, now this one I am showing. Now this is field direction, this is current direction. Field direction, see, I took in such a way, current direction. And see, magnetic force direction. Magnetic force direction, it is acting in downward direction. Okay, here the thumb is representing downwards. Okay, on AD face, thumb represents downwards. Okay, that is the force, downward force. Now in this case, thumb will be upwards in such a way. So thumb will be, now forefinger current, middle finger magnetic field, thumb points upwards. So in the case of BC, thumb is pointing upwards, so force is acting, magnetic force in upward direction. Right? This is not acting on these faces, but acting upwards from this face, acting downwards from this face. Means this force is pulling BC in upward direction, can I say? And this force is just pulling the DA in downward direction. So these forces now pulling BC upwards and pulling AD in downward direction. Just this magnetic force is not acting on these complete faces, because these three are not mutually perpendicular to each other. Here current and field direction are parallel to each other. So at each and every point, the angle between the field direction and current goes on changing. So here magnetic force is just pulling BC in upward direction and DA in downward direction. How it happens? Now BC, DA. Now in such a way, it is pulling BC in upward direction and DA in downward direction. Now in these cases, now one force is acting into the page, other force is acting out of the page. In such way, into the page and out of the page, in these two phases. Right? So now clear? Here these are mutually perpendicular to each other, so magnetic force effect will be on AB and CD phases. But here current and direction are parallel to each other, so magnetic force effect will not be on these two phases, but just magnetic force, what it will do, it just pull BC in upwards and AD in downwards. Now first, let us calculate the net force. Right? Now forces we got. Here the force is into the page. Here the force is out of the page. Force magnitude will be same. But one is into the, other is out to the, means they are in opposite direction. So now net force will be 0. Magnitude same but in opposite direction, so net force is 0 on this AB and CD faces. Similarly, on BC and AD faces also, magnitude of force is same. Why magnitude of force is same? Because here one, we took the uniform magnetic field and same current is flowing through the rectangular coil. Same current is flowing in uniform magnetic field. So force will not change. So the magnitude of force on this BC and AD faces will be also same. But one is acting in upward direction, other acting in downward direction. So here also net force will be equal to 0. Okay. Now what I said, if we take the net force on these two faces and these two faces are 0. Right? Net force is 0. Clear? Now, When net force is 0, then how the coil rotates? The question. How the coil rotates? Even though the net force is 0, coil is rotating, and that rotation is the main principle in electric motor. The rotation of coil in uniform magnetic field is the main principle of the electric motor. Then when net force is 0, then how coil rotates? Okay. Now here for this, let us take the example of this bottle lid. Now I want to open the bottle, the lid. I have to remove the lid. I opened the bottle, right? Now see, two fingers I'm using to make you understand. Now I closed the bottle with the lid. Now thumb, forefinger. Now how I am removing the lid? In such a way. See. Right? How? Now see. The force exerted by thumb is in downward direction. Okay, now see. I'm closing. Now see. Force exerted by the thumb is in downward direction, and force exerted by the forefinger is in upward direction. Right? Now see, thumb is exerting the force in downward direction. Forefinger is exerting the force in upward direction. So one force is downwards. Shall I draw here? One is downwards and other force is upwards. In such a way, one force is downwards, other force is upwards. Means forces are opposite to each other. But we call this as pair of force on opposite faces. Okay. So these two opposite faces. The pair of force, one inwards, one outwards. The pair of force on opposite in direction to each other constitute a couple. Constitute a couple. That couple we call it as torque. Now why we are considering only A and CD phases? Here for this we are not considering the forces on BC and AD. Why means these current direction and field direction are parallel to each other. So magnetic force doesn't act. Just it pulls upwards and downwards. So we are neglecting this BC and DS phases. So we are talking only about AB and CD phases. So the current direction and field direction are mutually perpendicular to each other. So magnetic force acts on AD and CD phases only. So here a pair of forces is there. One inwards, other outwards. A pair of forces is there. No. What this pair of forces doing? This pair of forces is allowing the lid to move. No? So in such a way only these pair of forces makes the coil to rotate in a magnetic field. So this pair of forces which are opposite to each other with the same magnitude, the pair of forces opposite to each other with same magnitude gives or constitutes a couple. Okay. So this moment of couple we call it as torque, and this torque is responsible for the rotation of coil in a magnetic field. Clear? So these two. Now assume this as the rectangular coil A, B, C, D faces. Okay, shall I write A, B. Now C, D. Now magnetic field. You are seeing the arrow marks now. Okay, I placed in magnetic field. Now what happens? This makes this rectangular coil. Now how I remove the lid? No, in such a way makes the rectangular coil to rotate in a magnetic field, and this is the principle on which the electric motor works. Right. Now here again one major problem is there. What in starting what I said, forces are same. Why forces are same? Because the same current is flowing through the circuit. When same current, now let us see the situation when same current flows in a coil. Situation 1, same current flowing in the coil. What happens means, first as usual, due to this couple, this coil rotates in, this is clockwise, this is anti-clockwise. This rotates, now coil in such a way, rotates in a clockwise direction, right, like this. Okay. Now in such a way, rotates in clockwise direction. But at the same time, now it rotates in a clockwise direction. Okay. But now these sides of a coil experiences forces. No, what I said, the sides of coil experiences magnetic force. Right. Now it is rotating. While rotating, the forces on the sides of coil reverses to the first case. In first case, what happened? Here the force is into the page. Here the force is out of the page. Now the coil has rotated, no? In such a way. First half, what is happening? This is the front face. This is the back face. Now in first half, here the force is into the page. Here the force is out of the page. Now what happens? In first half, the coil has rotated in clockwise direction. Now the top face went bottom and bottom face came up. Now what happened? The forces. Now here the forces will act into the page, here out of the page. Means forces reversed. When forces reversed, here into the page, here out of the page. When forces reversed, now what happens, for the first situation, the force has become opposite. The direction of forces has become opposite. Now here into the page, this is out of the page. Now coil comes to the halt. Means it stops. And again the coil, actually it has to go in such a way, no. Again the coil start rotating in clockwise direction in such a way. Sorry, anti-clockwise direction. I'm extremely sorry. Anti-clockwise direction. Again the coil rotates in anti-clockwise direction. And this continues. If the same current flows, in first half, it will rotate in clockwise direction. And in second half, it again rotates in anti-clockwise direction. Why? Because the sides are experiencing a force, and force direction becomes opposite to the first direction. What is the first direction? Here inwards, here outwards. And in second half, here again, here it becomes inwards. And here outwards. And it takes the anti-clockwise. So this continues clockwise, anti-clockwise. So in such a rotation, electric motor will not work. Now the electric motor will not work. Now the electric motor has to work. Electric motor has to work means coil must rotate only in one direction. In such a way, clockwise. See. Now AB. See. AB. AB went down. Again AB came to original position. The clockwise direction, the coil has to rotate in such a way. The coil has to rotate in clockwise direction only in one direction. So how to make the current to flow in one direction? Two possibilities are there. One, we have to reverse it. We have to reverse the magnetic field, or we have to reverse the current. But reversing the magnetic field is very, very complicated process. So it is better to reverse the current. So it is better to reverse the current. Okay, if we reverse the current, then this coil will rotate only in one direction, that is clockwise direction, and thereby our electric motor will work. So for reversing this, we will use commutator. Here what we have to do, here in this page I am showing. So we will use commutator. So commutator, it is a device used to reverse the direction of current. The direction of current, that we call it as commutator. So this commutator consists of two half slip rings. Right? Okay. Now see. Now in a uniform magnetic field we kept the rectangular coil. Now assume this has two slip rings. One I connected a pink color thread, other blue color thread. Okay, blue color thread. Now these are connected to the rectangular coil. A small gap will be between the two rings. Small gap only, here I will draw. Now this is the field direction. Right? Now I took the rectangular coil. Okay? I connected slip rings, that is commutator. A small gap is present between two. A small gap. Maximum they are closer to each other. A small gap. This we call it as slip rings. Now this we call it as shaft. Nothing but a iron rod around which our coil will rotate. Okay. Now to these slip rings, two brushes are kept in contact. Brushes. Okay. Let this slip ring be C1, this be C2, brushes B1, B2. Now slip rings are attached or connected to the coil in such a way they are connected to the two ends of the coil. Brushes just they are kept in contact. And these brushes are connected to the battery. Let this brush is connected to positive terminal and this brush is connected to the negative terminal switch. Negative terminal. Alright. Now see, rectangular coil. Right? Two slip rings with a small gap. Okay. Now let this be the brushes. Okay. One is connected to the negative terminal, other is connected to the positive terminal. I will remove the book and I will show. Okay. See. Right. Just for your idea, but you can prepare the electric motor. Now see. Now brushes you are seeing, no? One brush is connected to the positive terminal. Other brush is connected to the negative terminal of the battery. Right? Now see how the current is reversing. Here what we are seeing, how the current is reversing. Here our intention is to make the coil to rotate in only one direction, that is clockwise direction. For that we have to reverse the current. If same current flows, we will not have a only one direction of rotation for the coil. So electric motor will not work. For electric motor to work, we have to reverse the direction of current so that the coil rotates only in one direction. Now see. Now just slip rings are in contact to the brushes only. Okay, but these are fixed. Here, but fixed to the rectangular coil. Now fixed. Now what happens? Rectangular coil will start moving in clockwise direction. See my brushes. Slip rings. They are also moving, no? They are in contact with the brushes only. They are also moving. Okay? Right? Now both at a time I can't show. Now, first the coil is in such a way, just to understand the concept only. Now it is in anti-clockwise direction it is moving. So brushes also move. Again, it came in such a way. The brushes the slip rings which are in contact to the coil also move. Now coil came to this way. Okay. The slip rings also moved. Brushes will not move. Brushes will be constant. Brushes will not move. Now the coil has turned in such a way. Now the slip rings. Brushes will be in same way. The slip rings. Okay. Now slowly the coil is upper face is going down. Lower face is coming up. The slip rings also moves. Now see, the coil has came to this position and the slip rings came to this position. Now see, first the pink thread slip ring is towards this brush 1 and blue thread is towards this brush 2. But due to rotation, what happened? Now pink thread came to the brush 2 and blue thread came to the brush 1. So first, in case 1, the pink thread is slip ring is connected to the positive terminal. And in half of the rotation, this has connected to the negative terminal. Now again. Now slip rings also rotates as per coil, and when coil comes, again the slip rings, pink comes to the positive and this go to the negative. Right? So here what happens? So slip rings also move because these are connected to the coil now. Okay, these are connected to the coil now. So slip rings also move accordingly to the coil. So in such a way, they will be in contact with the brushes. Brushes will not move. Just as coil is rotating, the slip rings are also rotating in such a way. These are in contact to the brushes. Now see. See, pink. Just focus on the pink thread. Now see. In first half, pink thread from brush 1, it has came to brush 2. Brush 1 is of a positive charge and brush 2 is of negative charge. Means first pink thread is at positive and in first half it came to the negative. So current is reversed or not? Yes, current is reversed. And again in next half, again focus on pink thread only. As the coil is rotating, the slip rings also rotate in such a way. And again pink thread, that is slip ring, came to the positive and again blue thread came to the negative. Means again the current has reversed its direction. So in such a way, by using the commutator, we will reverse the direction of the current. And as we reverse the direction, the coil will move in only one direction, that is clockwise direction, in such a way. In magnetic field, the coil first half, second half. So these two halves creates one complete rotation and the process repeats and electric motor works. Right? The process repeats and electric motor, and this is the principle of electric motor, reversing the current and making the coil to rotate only in one direction, that is clockwise direction, is the principle of electric motor. And what is the use of electric motor? It converts electrical energy into mechanical energy. Can you give the example? Your mixers, grinders, mixers. So we will send current only, no? That converts into mechanical energy and grind all the particles which we pour in the mixer jar. Okay? If you like my video, like it, share it, subscribe it. This is all about electric motor. Stay with my channel, Reshma Physics. Thank you.